Impact Report predicted 50% increase in problem-solving efficiency across education AI and robotics sectors by Q2 2025. Overview. By the second quarter of 2025, a transformative shift is anticipated across the education artificial intelligence AI and robotics sectors, with experts predicting a remarkable 50% increase in problem-solving efficiency. This surge is expected to stem from the rapid integration of innovative AI-driven educational tools and advancements in robotics technology. Key predictions and trends. 1. Integration of AI in education. Adoption and implementation. Educational institutions are projected to increasingly adopt AI technologies to enhance operational efficiencies and personalize learning experiences. The deployment of AI-driven analytics for resource allocation, attendance tracking, and engagement monitoring is becoming prevalent. Source 2. Professional development. A significant rise in professional development courses focusing on AI literacy, labeled AI 101, is expected. These courses aim to equip educators with essential skills to leverage AI while considering its ethical implications. Source 2. 2. AI's role in teaching and learning. Automation of administrative tasks. The anticipated advancements in AI are expected to automate routine administrative tasks, allowing educators to dedicate more time to instruction and student interaction. Adaptive learning technologies will enable the customization of educational content to accommodate diverse student needs. Source 2. Intelligent tutoring systems. Educational applications are predicted to increasingly feature intelligent tutoring systems that provide instant feedback and identify learning gaps, suggesting targeted interventions tailored to individual student needs. Source 2. 3. Robotics and automation in industry. Increased usage of autonomous robots. In the robotics sector, experts forecast a heightened utilization of autonomous mobile robots and humanoid robots, particularly in warehouses and logistics. Responding to growing demands for efficiency. Source 1. Innovations in robotics. Innovations such as advanced vision systems and collaborative robots cobots are expected to play a vital role in enhancing the capabilities and efficiency of robotic systems across various industries. Source 1. 4. Legislation and ethical considerations. Navigating legislative barriers. As educational institutions pursue AI integration, there is concern about potential legislative barriers that could hinder the efficacy of AI tools intended to support learning. Source 2. Ethical implications. The ethical considerations surrounding the use of AI in classrooms emphasize the need for careful deliberation regarding the adoption of generative AI tools versus traditional learning aids. Source 2. Common themes across sources. Transformative potential of AI. Both the education and robotics sectors underscore the transformative potential of AI in enhancing operational efficiencies and personalizing experiences for users. Emphasis on professional development. A recurring theme highlights the necessity for professional development and ethical considerations, stressing the importance of informed implementation of AI technologies. Differences between sources. Focus areas. Source 1 predominantly emphasizes advancements in robotics and their impact on various industries, while Source 2 focuses on the implications of AI within the educational landscape, particularly in teaching methodologies and administrative efficiency. Perspective. Source 1 adopts an industry-centric perspective, while Source 2 provides insights into educational implications and the legislative frameworks necessary for effective AI integration. Timeline of events. 2024, initial predictions regarding the role of AI and robotics in enhancing operational efficiencies emerge. January 2025, industry experts share insights and predictions about the evolving landscape of AI in education and robotics, highlighting the importance of ethical frameworks and professional development. Q2 2025, a projected 50% increase in problem-solving efficiency is expected due to advances in AI-driven educational tools and robotics technologies. Conclusion. The anticipated rise in efficiency across the education AI and robotics sectors signals a transformative period ahead. Integrated technologies are poised to profoundly influence operational practices and learning experiences. Stakeholders in these fields must remain vigilant about the ethical implications of these technologies, ensuring that implementations foster equitable access and support for all students. Source summaries. 1. Source 1, Robotics 24/7. This source discusses predictions from industry leaders regarding the impact of robotic technologies in 2025, highlighting the expected increase in the usage of autonomous robots and the innovations that will shape the future of the industry. 2. Source 2, The Journal. This source focuses on the expected impact of AI in education, detailing how educational institutions will adopt AI to enhance operational efficiencies and personalize learning experiences, alongside discussions on professional development and ethical considerations. The convergence of AI and robotics within educational settings is set to redefine traditional methodologies, making learning more personalized, efficient, and inclusive. As these technologies evolve, it is critical for educators, policymakers, and industry leaders to collaborate in navigating the challenges and opportunities presented by the integration of AI and robotics in education and industry. The content presents various predictions about the expected 50% increase in problem-solving efficiency across the education, artificial intelligence, AI, and robotics sectors by the second quarter of 2025. Here are several counterintuitive insights derived from the information. 1. AI is a complement, not a replacement. While many anticipate that AI will automate various administrative tasks, allowing educators to focus more on teaching, there is a notion that this increased efficiency will not necessarily lead to fewer educators being needed. Instead, the emphasis is on how AI can complement human instruction rather than replace it. This counters the common fear that automation will lead to job losses in education, suggesting that the role of teachers will evolve rather than diminish. 2. Legislation as a barrier to progress. Despite the optimism surrounding AI's integration in education, experts warn that legislative measures aimed at regulating AI could inadvertently hinder its beneficial applications. This creates a paradox where efforts to ensure safe and ethical use of AI might restrict access to essential tools that genuinely enhance learning. This suggests that the push for regulation, often viewed as a protective measure, could have unintended negative consequences for educational advancement. 3. Professional development's critical role. The expected rise in AI 101 courses for educators indicates a shift towards recognizing the importance of professional development in technology adoption. This counters the assumption that simply implementing technology will inherently lead to improved outcomes. Instead, there is a clear acknowledgement that without adequate training and understanding of AI's capabilities and limitations, the anticipated benefits may not materialize. For the diversity of AI applications. The diversity of AI applications in education, ranging from administrative automation to personalized learning experiences, highlights that AI's impact is not monolithic. This counters the narrative that AI will only affect one aspect of education, such as teaching or administration, showing that its integration could lead to widespread changes across multiple dimensions of the educational experience. 5. Human-centric AI integration. The emphasis on creating inclusive learning environments through AI technologies suggests that rather than alienating students or making learning more mechanical, AI can foster a more personalized and engaging educational experience. This counters the critique that AI may depersonalize education, demonstrating that when thoughtfully integrated, AI can enhance human connection in learning. 6. Robotics efficiency versus job displacement. In the robotics sector, while autonomous robots are expected to increase efficiency, there's an acknowledgement that this doesn't necessarily lead to widespread job displacement. Instead, it suggests a transformation of work roles within industries where human workers may take on more complex tasks that require creativity and critical thinking, skills that robots cannot replicate. This challenges the prevailing fear that automation will lead to significant unemployment. 7. AI as an equity tool. The predictions suggest that AI could be a powerful tool for promoting equity in education. This is counterintuitive given the common discourse that technology often exacerbates educational inequalities. Instead, the potential for AI to personalize learning experiences, identify gaps, and provide tailored resources indicates that it could help to level the playing field for all students, particularly those from disadvantaged backgrounds. 8. Complexity of AI integration. The content highlights that successful AI integration is not merely a technical challenge but involves navigating complex ethical considerations and legislative landscapes. This counters the simplification of technology adoption as merely a matter of purchasing and deploying new tools, illustrating that the socio-political context significantly shapes how technology is utilized in practice. 9. Demand for critical thinking in AI use. The need for educators to critically assess the role of AI in education reflects a growing recognition that technology can have both positive and negative implications. This counters the narrative that technology is inherently beneficial, emphasizing the importance of discernment and ethical considerations in leveraging AI for educational purposes. In summary, the predicted advancements in education AI and robotics suggest a nuanced landscape where efficiency gains may not follow the expected trajectories of job loss or depersonalization. Instead, these sectors may experience transformative changes that enhance human roles, promote equity, and necessitate critical engagement with technology. The report predicts a significant 50% increase in problem-solving efficiency across the education, artificial intelligence, AI, and robotics sectors by the second quarter of 2025. While much attention may be paid to the broader implications of AI in these fields, there are crucial, often overlooked aspects that merit deeper exploration. Here are some significant insights that could be easily missed along with their implications. 1. The role of AI in teacher development. Overlooked content. The report highlights the expected rise of AI 101 professional development courses designed to equip educators with the skills to leverage AI technologies and understand their ethical implications. Significance. This is significant for several reasons. Firstly, it indicates a shift towards a more informed teaching workforce that can critically assess and implement AI tools in classrooms. Understanding AI is essential for educators not only to enhance their teaching efficacy but also to guide students in navigating an increasingly AI-driven world. If teachers lack this foundational knowledge, the integration of AI could lead to misapplication or even resistance to technology that could enhance learning outcomes. 2. Legislative impacts on AI integration. Overlooked content. The report notes potential legislative barriers that could hinder the efficacy of AI tools in education. This includes the prediction of increased state and federal legislation governing the use of AI in classrooms. Significance. Legislation can have a profound impact on how schools can utilize AI tools. If laws are enacted without a comprehensive understanding of AI's benefits, they could restrict access to effective learning technologies. Educators and policymakers must prioritize collaboration to ensure that legislation supports rather than stifles innovation in educational tools. This balance is crucial for maximizing the potential benefits of AI while protecting student welfare. 3. Ethical considerations in AI tools. Overlooked content. The report emphasizes the ethical concerns associated with AI in education, particularly the distinction between generative AI tools and those that are safe and tested for student use. Significance. This distinction is vital as the adoption of educational technologies accelerates. Generative AI tools can be powerful but also pose risks such as bias and misinformation. Understanding these nuances is crucial for educators to make informed choices about the tools they use. Ethical considerations should guide the development and implementation of AI in education to foster a safe and equitable learning environment. 4. Adaptive learning technologies. Overlooked content. The potential of adaptive learning technologies to personalize educational experiences is highlighted, but the depth of their impact is often understated. Significance. Adaptive learning technologies can significantly enhance student engagement by tailoring educational content to individual learning styles and paces. This personalization could lead to improved outcomes and a more inclusive educational environment. However, it also requires careful implementation and ongoing assessment to ensure that it meets diverse student needs effectively. The educational community must be prepared to continuously evaluate and adjust these technologies to maximize their benefits. 5. The integration of robotics in education. Overlooked content. While the report discusses robotics in industry, the application of robotics in educational contexts is not as prominently featured. Significance. Robotics can play a transformative role in education by providing hands-on learning experiences that enhance problem-solving skills and critical thinking. As schools increasingly integrate robotics into curricula, this could foster a new generation of learners who are not only consumers of technology but also creators. This aspect is significant as it aligns with the growing emphasis on STEM education and prepares students for future workforce demands. 6. The need for continuous professional development. Overlooked content. The necessity for ongoing professional development in AI and robotics is mentioned but is sometimes minimized in discussions on implementation. Significance. As technology evolves rapidly, continuous professional development is essential for educators to stay current with new tools and methodologies. This need is particularly urgent in a landscape where AI and robotics are expected to become more integral to educational practices. Ensuring that educators have access to ongoing training will be crucial in maintaining the effectiveness of AI tools and enhancing educational outcomes. 7. Equity in AI implementation. Overlooked content. The report touches on equity but does not fully explore how AI can both positively and negatively influence equitable access to education. Significance. AI has the potential to level the educational playing field by providing personalized learning experiences that cater to diverse needs. However, if access to AI technologies is inequitable, it could exacerbate existing disparities. Stakeholders must focus on ensuring that AI tools are accessible to all students, particularly those from underserved communities. This commitment to equity is vital for the successful integration of AI in education. Conclusion. The predicted increase in problem-solving efficiency due to advancements in AI and robotics is indeed promising. However, the nuances surrounding teacher development legislation, ethical considerations, adaptive learning, robotics in education, continuous professional development, and equity are critical areas that require careful attention. By addressing these overlooked aspects, stakeholders can harness the full potential of AI technologies to enhance educational outcomes and prepare students for a future where AI and robotics play increasingly central roles. 1. Integration of AI in education, transforming learning environments. The predicted 50% increase in problem-solving efficiency underscores the growing importance of integrating AI within educational systems. Educational institutions are expected to leverage AI-driven analytics to enhance operational efficiencies, including resource allocation and student engagement tracking. The emergence of professional development courses like AI 101 highlights the necessity for educators to understand and utilize AI, ensuring they are well equipped to navigate the ethical implications and practical applications of these technologies. This shift could lead to more personalized learning experiences addressing individual student needs and fostering inclusivity. 2. AI's role in teaching and learning, empowering educators. AI's potential to automate administrative tasks allows educators to concentrate on core teaching activities and student interaction. The development of adaptive learning technologies is particularly significant as these systems can tailor educational content to fit diverse learning styles. Moreover, intelligent tutoring systems offer instant feedback and pinpoint learning gaps, providing targeted interventions tailored to individual student needs. This capability not only enhances the learning experience but also ensures that all students receive appropriate support in challenges, paving the way for improved educational outcomes. 3. Robotics and automation, enhancing operational efficiency. The robotics sector's anticipated growth, particularly in the use of autonomous mobile robots and humanoid robots, aligns with the overarching theme of enhancing operational efficiency across industries. Experts predict that advancements in vision systems and collaborative robots cobots will play a critical role in improving the capabilities of robotic systems. This transition is driven by the necessity for increased efficiency in logistics and manufacturing, suggesting a significant impact on productivity and operational excellence. The integration of robotics within various sectors, including education, can also lead to innovative learning methodologies and practical applications for students. 4. Legislation and ethical considerations, navigating challenges. As AI becomes more integrated into education, concerns surrounding legislation and ethics emerge. The potential for new state and federal regulations could inadvertently hinder the deployment of effective AI tools that support learning. Furthermore, understanding the differences between generative AI tools and educational applications with proven algorithms is critical for educators and policymakers alike. This emphasizes the need for informed decision-making to ensure that AI technologies are implemented responsibly, fostering equitable access and support for all students while addressing ethical concerns. The focus on ethical integration will be vital as stakeholders navigate the evolving landscape of AI in education and beyond. Here are 3 famous historical cases that illustrate significant advancements in problem-solving efficiency through technology and innovation, similar to the predicted impact of AI in education: artificial intelligence and robotics. 1. The Industrial Revolution, late 18th to early 19th century. The Industrial Revolution marked a major turning point in history, transforming economies that had been based on agriculture and handicrafts into economies based on large-scale industry, mechanized manufacturing, and the factory system. Key innovations such as the steam engine, spinning jenny, and power loom significantly increased production efficiency. This period saw a dramatic increase in problem-solving capabilities across various sectors, including textiles, transportation, and manufacturing. The introduction of machinery allowed for faster production, reduced labor costs, and improved product quality, paralleling the expected 50% increase in efficiency through AI-driven tools. 2. The Enigma machine and code breaking during World War II, 1930s to 1940s. During World War II, the use of the Enigma machine by the German military for encrypted communications posed a significant challenge for the Allied forces. The development of code-breaking techniques, particularly by mathematicians and logicians at Bletchley Park, led to the creation of early computing machines such as the bomb, designed to decode Enigma messages. This technological advancement allowed the Allies to intercept and decipher German communications, greatly enhancing their strategic problem-solving capabilities in warfare. The efficiency gained in intelligence operations through these innovations had a profound impact on the outcome of the war, akin to the anticipated efficiencies from AI in modern sectors. 3. The Green Revolution, mid-20th century. The Green Revolution refers to a series of research, development, and technology transfer initiatives that occurred between the 1940s and the late 1960s, leading to significant increases in agricultural production worldwide, particularly in developing countries. Innovations such as high-yielding varieties of staple crops, the use of chemical fertilizers, advanced irrigation techniques, and pest control measures dramatically improved food production efficiency. This transformation helped alleviate hunger in many parts of the world and demonstrated how technology could enhance problem-solving efficiency in agriculture. Similar to the expected advancements in education and robotics through AI-driven tools, these historical cases exemplify the transformative effects of technological advancements on problem-solving efficiency across various sectors, paralleling the anticipated impacts of AI and robotics in contemporary society. By the second quarter of 2025, a remarkable transformation is anticipated across the education, artificial intelligence, AI, and robotics sectors, with a projected 50% increase in problem-solving efficiency. This forecast stems from the convergence of advanced AI-driven educational tools and cutting-edge robotics technologies that are set to reshape these industries. Key predictions and trends. 1. AI integration in education. Educational institutions are expected to increasingly leverage AI to enhance operational efficiencies and personalize learning. AI-driven analytics will optimize resource allocation, attendance tracking, and student engagement monitoring. A surge in professional development programs such as AI 101 courses for educators is anticipated, aimed at equipping them with the skills to utilize AI effectively and understand its ethical implications. 2. AI enhancements in teaching and learning. AI will automate many administrative tasks, allowing educators to dedicate more time to effective teaching and student interaction. Adaptive learning technologies will personalize educational content to cater to diverse learning styles, promoting an inclusive educational environment. Intelligent tutoring systems will provide real-time feedback, identifying gaps in student knowledge and recommending targeted interventions. 3. Advancements in robotics. The robotics sector is expected to see a significant increase in the deployment of autonomous mobile robots and humanoid robots, particularly in logistics and warehousing. This shift aims to meet the growing demands for efficiency and productivity. Innovations like advanced vision systems and collaborative robots cobots will enhance robotic capabilities, making them more versatile and efficient in various applications. 4. Legislation and ethical considerations. The rise of AI in education will prompt new state and federal legislation aimed at regulating its use in classrooms. However, there is concern that such regulations may inadvertently hinder the efficacy of valuable AI tools. Ethical considerations surrounding AI application in education will gain prominence, necessitating a careful evaluation of generative AI tools versus traditional learning aids. Common themes across sectors. A shared vision of AI's transformative potential in enhancing operational efficiencies and personalizing experiences is evident in both the education and robotics sectors. The emphasis on professional development and ethical considerations highlights the importance of informed implementation of AI technologies. Differences in perspectives. The robotics sector focuses primarily on industrial advancements and operational predictions, while the education sector highlights the implications of AI on teaching methodologies and administrative functions. While robotics discussions center around efficiency and productivity enhancements, educational discourse is more concerned with the ethical implications and effective integration of AI into learning environments. Timeline of developments. 2024, predictions regarding the impact of AI and robotics on operational efficiencies begin to emerge. Q2 2025, a significant increase in problem-solving efficiency is expected, driven by advancements in AI-driven educational tools and robotics technology. January 2025, industry experts share insights on the evolving landscape of AI in education and robotics, emphasizing the need for ethical frameworks and professional development initiatives. Conclusion. The anticipated rise in problem-solving efficiency within the education, AI, and robotics sectors heralds a transformative era. This evolution will fundamentally alter operational practices and learning experiences, driven by the integration of innovative technologies. Stakeholders must remain vigilant regarding ethical implications and ensure equitable access to these advancements, fostering an environment that supports all students effectively. The future looks promising, with AI and robotics poised to create more personalized, efficient, and inclusive educational and industrial landscapes.